Hey, welcome back to Kinematics. So this is lesson 3, and we are going to work through another free fall problem. Okay, so here is the problem, and the problem says Luke drops a pile of roof shingles from the top of a roof located 8.52 meters above the ground. Determine the time required for the shingles to reach the ground. Okay, Luke's always dropping stuff off the roof. So, here's our roof. Let's just say that's the roof. And he drops a shingle off the top of the roof. And the roof is, what, 8.52 meters. Delta X. Okay, so there's our diagram. And let's go ahead and try and put down the givens that we know. So we know delta x equals 8.52 meters. Let's see, we know the acceleration of gravity on Earth is 10 meters per second squared. Now in the last problem it said that in the question, but if it doesn't say it, we just assume that we're on Earth and the acceleration of gravity for Earth is constant and it's 10 meters per second squared. And what else do we assume? Well, we assume that the shingle, or the pile of roof shingles, right before they started falling, they were in Luke's hand and their initial velocity was 0 meters per second. And to make this easier for us, let's say that x initial equals 0 meters. So x initial equals 0 meters. Okay, so what's our unknown? Our unknown is what it's asking us to solve for. So determine the time. Determine the time required for the shingles to reach the ground. So our unknown is time. Okay. So our equation, to me this looks a lot like the same problem that we got rid of. What is that? I don't know how that got there. But anyways, we are going to use this equation. And the equation is delta x equals x initial plus velocity initial times time plus 1/2 at squared. Alright, just like last time. So x initial is 0 and velocity initial is 0. So let's just go ahead and get rid of those. Don't need those anymore. Delta x equals 1/2 at squared. Okay. Got to get t by itself. First thing to do, multiply both sides by 1. No, multiply both sides by 2. So you multiply both sides by 2, cancels out this 1/2. And we have 2 delta x equals at squared. And the next step is to get rid of this a. So divide both sides by a, and that goes away. 2 delta x divided by a equals t squared. And the last thing we need to do is get rid of this exponent of 2. And in order to do that, we got to take the square root of both sides. So our final equation is t equals the square root 2 times delta x divided by a. And now put in our numerical values. T equals 2 times 8.52 meters divided by t squared. What's t? Oh, a squared, I'm sorry. No, not a squared. Okay, a, just a, which is 10 meters per second squared. Hope I didn't confuse you. Okay, so t equals square root 2 times 8.52. I'm going to use my calculator for that. 2 times 8.52, 17. It's actually 17.04, but I'm just going to put 17 meters. 17 divided by 10 meters per second squared. So let's see, 17 divided by 10 equals 1.7. So t is the square root of 1.7 seconds squared, which equals 1.7, which equals 1.3 seconds. And that is our final answer for time. So let's just check and see if that's correct. Okay. Oops. Alright, sorry about that. Let's see. Okay, here's the problem. Let's see where the solution is. So, okay, solution's right here. T equals 1.32. What do we get? We got T equals 1.3. Close enough. So, if I would have kept that 1.704, 17.04, whatever that was, that's probably where that extra 2 disappeared to. But 1.3 is a perfectly good answer. So that's another free fall problem to chew on. All right.